on Build, Grow, and Enjoy. An amazing, amazing guy. John Rapp is with us. We're going to go to the telephones, let John do a brief introduction on himself, and then we're going to spend a good time here, most of our program here today, talking with John Rapp. John, go ahead and give us a brief introduction on yourself, my friend.
Hi, I'm John Rapp from Staten Island. I'm just a regular sort of working guy, except that I make comic books about science fiction. And I draw a lot of inspiration from YouTube videos, and I've been noticing lately these flat earth videos that are up like thousands of % compared to previous years. And I'm sort of working that in. The flat earth frisbee, which I think we're going to talk about in a minute, is my first sort of step into, publicly in that flat earth debate. But I sort of have a lot to say about it, more than just the frisbee, but the frisbee's a great sort of conversation starter. You can just look at it, and it's got the flat earth map on the top of the frisbee, and you go from there. You talk theory, looking at the map.
We've got John Rapp with us today. He joins us live here in our program talking about a flat earth frisbee. Tell us, is there an Indiegogo or anything we can get people out there to take a look at while we're talking here today?
Right. It's if you go to Kickstarter, or if you even just Google Flat Earth Frisbee, it'll come up with the Kickstarter project. There's just a few days left, so you got to sort of hurry to get there. Yep. But it's only $5, which I think, if you went to the store, I don't know how much Frisbees are going for, but considering that I had to design the logo and get them printed, and it's the best I can do. But I think that $5 is a fair price. So go to Kickstarter, Flat Earth Frisbee. You can get them there. You can get one if you want it, or you can get them in a few, or you can get up to a 10-pack. That'll reduce the per unit price to about $3 if you get a 10-pack. And there's a postcard that I designed to go with the project that has on the front of it, it has my own sort of idea about how a flat earth would work. You have to sort of see this picture. It's hard to describe, but it's basically, you got to see it. But on the back of the picture, on the back of the postcard, I've got some of the most compelling arguments for the flat earth, which I think people would be really surprised how solid the theory is. Considering we all have been told and believe that we live on a sphere, but these flat earth arguments have been building for hundreds of years, and they've got them pretty tight at this point.
We've got John Rapp with us today, joining us here on Build, Grow, and Enjoy, the BGE Radio Network, each and every Friday here on such great radio stations out of Atlanta, GA. We thank John Rapp for joining us today. Let's talk a little bit about drawing some distances in video games, using false reality, sort of like if a tree falls in the woods. Kind of talk to me about that.
Yeah, that's. I think that's the reason for the explosion. It all started. Well, I don't know when it started, but the first I heard of it was a few years ago on the first-person shooter on the Xbox. For me, it was Halo. Some people might have seen other games. And Halo is a very outdoor game. It has these outdoor maps and these mountain ranges, and it has oceans and stuff. So the draw distances on an outdoor map become important because you potentially could see, as far as your eye could see. There's no wall, it's not an interior map. You're not in a dungeon, you're outdoors. So they need a draw distance, so they need to draw it as far as your potentially eye could see. So they were drawing, 3 miles or something like that. And they were drawing it flat because it's just a video game. It's not like the Earth. They're just drawing it flat. And it looked pretty good. They would do these 3 or 5 mile draw distances, and they were flat, and it looked pretty good. So that was 10 years ago. Fast forward to the future, now I'll use Grand Theft Auto 5 as an example, which is, I believe, one of the 2 most popular games on Xbox right now and some of the other systems as well. the draw distances are many miles. And in fact, you can go up in planes, helicopters, rockets, balloons, all the things you can do in real life. You can have like submarines. You can do that stuff in GTA 5, and it's got these draw distances that go on multi-miles. And they look good, and they're still flat. Now, how is this possible? That we live on a spherical Earth, and these video games that are rendered flat, they look real. So I mean, they're not real. And this is the tree falls in the woods thing. Is if a tree falls in the woods and nobody hears it, it doesn't make a sound. Well, in a video game, it doesn't. There needs to be a player within a certain radius, and it renders. So, for example, in GTA 5, the map might be spherical, but it renders in a flat radius around the player. So it's not like it's if you were to travel, it would be in theory a sphere, but if you were to look, it would be flat. And in fact, this is sort of an anecdote, so you can't quote Halo or GTA 5 in this, but this is sort of an anecdote that I've heard from the gaming world, is that when they tried to account, some developers, some programmers, some of the guys who make the engines that the other games run on, they tried to develop a world using the spherical geometry that they know to exist in the world, like using physics, using astrophysics and cosmology and the things we know about the universe. And when they tried to render a spherical Earth in the video game, they ended up getting towers. They ended up getting buildings that would lean like the Tower of Pisa. And of course, that's not what we see in reality. If you look, whether it's in a video game or you look from a real-life helicopter, you can see a city that's like 30 miles away, and the buildings are perfectly straight. And so in the video game, they're perfectly straight because it's a flat video game world. And if they tried to make it bend like the curve of the Earth, the building would bend. And that wouldn't look right. So they don't do that. Now, you can ask a physicist, why is that? Why is the video game rendered flat and it looks like the real world that's curved? And the answer is light refraction. So that's the official answer. So, we can sort of, I'll leave that at the end of the video game. I have some other ideas, but let me sort of send it back to you on that note.
We've got John Rapp with us today. He joins us here on Build, Grow, and Enjoy. He joins us live today talking about his Flat Earth Frisbee, and he joins us here on BGE Radio. Now, you were talking there about some game engineers experimenting with building Earth curvature into video game draw distances with buildings that ended up looking like the Leaning Tower of Pisa. Now, I want to follow up here. Round satellite images from NASA and Google Earth are actually composites. Worse, they are composites of image provided by subcontractors and put into models that are assumed to be basically balls before any of the images are mapped on. Explain that to our audience.
Right. When you go and use Google Earth, or if you look at pictures from NASA, but I would say sort of for your own experimenting, you would use Google Earth because it's an interactive program. You can sort of lift the camera up and you could spin the Earth around, and it's actually a lot of fun to use. You can start with your house, and you can bring the camera up to plane height, and you could rotate the Earth underneath you and fly down in any part of the world you want, and it's very cool. But it's not like there's one satellite that's like circling the Earth and taking the entire image on Google Earth. Now, I can't speak officially for Google Earth, but what I've learned from reading articles and watching videos is that what you see on Google Earth is composite images that are taken from multiple sources. Multiple contractors create these images with various, satellites and spy planes and whatever other technology they use to take these pictures. And then these pictures, they're overlapping. So they need to be combined together. That makes them a composite image. And they need to be combined together in some way. So, like, for example, if you ever see a square map, that's, usually if you book an airline, they show you the rectangular map that's called the Mercator projection. That's one projection. the sphere Earth, whether you assume that this is, the correct shape of the Earth or not, it's still a projection because it's still, a model that you have to map these images onto. So it's like, imagine if you took a basketball and you wallpapered a bunch of satellite images of the Earth onto it until you constructed a globe. In a digital way, that's what Google Earth is doing. So they've got, piles and piles of images. They're not piles, they're actually folders full of files. But they've got all these images, and they've got a model that they're sticking the images onto, and the model is like a perfect sphere. Now, if you ask Neil deGrasse Tyson what's the shape of the Earth, he tells you it's an oblate spheroid, which is kind of like a pumpkin shape. I mean, that's not what you see on Google Earth, because Google Earth is composite images layered onto a perfect sphere. So you're getting composite images laid into an assumed model. These images come from multiple sources. There's no one sort of definitive image that tells you, that puts everything in perspective without assumptions. And you might say, well, I'll just go to NASA. They have, they're these space people. Turns out NASA does the same thing. They make composites of overlapping images too. They do them great. They look amazing. But they're composites,
John Rapp with us today joins us here on our program, Build, Grow, and Enjoy, from BGE out of Atlanta, GA. Now, you were mentioning the Hubble telescope. It has basically the same problem, similar to an electron microscope. Tell us a little bit about this.
If you studied in school, maybe you saw pictures from an electron microscope, or maybe even got to look at one. So an electron microscope, which you can see in your local science classroom, or, at least university, someone who has money, to get such a microscope. It's not like Galileo with his multi-lens, telescoping, apparatus to see the stars. This is a device that, sends waves and times the return of the wave, and it uses that to calculate what it's seeing. So let's say it's seeing some germ or whatever it's seeing, some tiny microscopic thing. So it comes back with basically a black and white, kind of like a wire mesh image. That's the same thing that Hubble telescope does. It's the same concept. There's you see these great pictures from NASA, amazing looking images, and they're coming from something that doesn't take pictures, it collects data. And that data needs to be rendered. And the rendering is based on formulas that were already written, which were based on, I don't want to call that, based on theory. To me, I feel like calling them assumptions, because I feel like anything that's not, it's like when we went from the analog world to the digital world. In the digital world, you capture data and you reproduce it. That's why you don't have static in digital. You know this as a radio person. So that's why the images from NASA are perfect. There's not like someone's taking a picture. Someone's collecting data. They're collecting that data and turning that into a picture. So you just need to be aware of that. I'm not saying that it's necessarily wrong, but sometimes when you see an image that's too good to believe, there's a reason. There's probably a reason it looks so amazingly good. It's because it was finished by the art department. It was, the computer made it was collected as data, like an Excel spreadsheet. The computer rendered it into a wire mesh model, and then an artist finished it using, some more collected data as guidance. But in the end, it's almost a painting.
We've got John Rapp with us today. He joins us here on Build, Grow, and Enjoy. The BGE Radio Network each and every Friday on such great radio stations out of Atlanta, GA. The flat map reveals a secret that the ball is hiding. If you divide the flat map into 8 pizza slices, you see that we have very little information on one slice. It's the slice with Easter Island. Tell us more, John.
Yeah. This one's my favorite, and in fact, I haven't heard the flat earthers on YouTube talk about it. Not that I've seen every video, but I've seen some of the most popular guys, and they like to talk about how Antarctica, on the flat Earth map, Antarctica goes around the outside. So on a normal sphere globe or map projected based on the concept of a sphere, you have the North Pole at the top, you have the South Pole at the bottom. The South Pole is somewhere in the middle of the continent of Antarctica. On the flat Earth map, it's a disc-shaped. The North Pole is at the center, and Antarctica goes all the way around the outside. And you see this on the Frisbee. This is one of the reasons I made the Frisbee. It's just to sort of get that visual out there to help the conversation. So some of these people on YouTube who do these flat Earth videos, they want to know what's beyond that Antarctic ice wall. Could you climb that wall? Could you fly over it? Could you send a balloon? Could you go seeing what's there? And they're sort of taking bets on what's there. Some people say it's a wasteland. Some people say you'll end up on the other side and it's just regular Antarctica as we understand. Some people say it's a dome and we're locked in. And then some people say, well, if you take the right angle, or if you just keep going in any angle you take, you'll eventually get to another flat Earth, or another flat whatever. I think geothermal pod is the popular term for it. This idea that we're living in a ice age, and what we believe to be Earth is one sort of cutout of that ice, or one sort of heated up, puddle, and that maybe you can get to others. But I think they're overlooking something that we can more easily check than what's beyond Antarctica. So if you look at that flat Earth map, there's more ways than one. There's more ways besides Antarctica that it differs from the rectangular Mercator projection. In fact, here's an experiment. If you ever fly a multi-continental route, especially one where it stops for gas, map the 3 points on the Mercator projection, where you start flying, where you're finishing, and where the plane stops to refuel. On the Mercator projection, you will often get a triangular sort of route. For example, if you went from Auckland to Santiago and you stopped to refuel in San Francisco, you're going from southern hemisphere to southern hemisphere, but you're stopping in the northern hemisphere to gas up. Doesn't make sense on the Mercator projection. But on the flat Earth map, it's a perfectly straight line. So if you assume that the Mercator projection is distorted, and I think based on how many people use the flat Earth map, like the Civil Aeronautics, U.S. Geological Survey, International Weather, and International Maritime, in fact even the UN uses this flat Earth map, you start to become convinced that maybe that Google Earth map and that Mercator projection, maybe the continents are not quite at the right angles, because you would think that the plane would want to fly straight. And on the flat Earth map, if you plot the to, from, and gas point, it ends up being straight. I wish I could show you a picture here. Tough to do on the radio, but Auckland to Santiago, stopping in San Francisco. Plot that one on Mercator and then flat Earth and see what it looks like. So let's say you then say, okay, there's something to this. These continents are at these angles and these positions. Well, what becomes interesting when you assume that is that there's a lot of space that we don't go to. In fact, that Pacific Ocean would become much bigger than we realize it is. In fact, if you were to take the flat Earth map and cut it up into 8 pieces like a pizza pie, you would find that there's one slice that we don't go to. And that's the one slice that happens to have that Easter Island in it. But it's it's like an eighth of our world if this map is correct. And we only know about like this, one little area in it, and that one little area happens to be one of the most fascinating places. I don't know. I want to check that out, see what else is there. I mean, maybe it's just water, but even the water, let's see what's in the water. There's probably some big sea creatures where they've got a lot of water to work with. Who knows what's out there?
We've got John Rapp with us today. Joins us today here on Build, Grow, and Enjoy. And he's with us today talking about this incredible flat earth Frisbee. We were talking a little bit about flat earth there. Let's talk a little bit about the Indiegogo campaign before we keep talking here. Give us a refresher on that. What exactly are you trying to do? The link, all the stuff. Tell us about it. Let's get the advertising here, my friend.
Well, it's on Kickstarter. If you go to Kickstarter and search either Frisbee, Flat Earth, or Flat Earth Frisbee, anything will take you there. So it's a Frisbee. It's not the sort of official Frisbee size for competitive reasons. It's about 10-inch Frisbee. It has a blue color to it, sort of like the blue waters, and on white it has the Flat Earth map on top of it. So it's just a Frisbee for $5. You get a 10-pack for $33, and you get a postcard with it, which shows one of these concepts for what's beyond the flat Earth. And my particular concept, which is not based on any science, it's more based on science fiction because I like to write science fiction. You really have to go to the Kickstarter just to see this image. It's a polygon sphere with 20 panels. Each panel is a triangle. Each triangle has its own flat Earth pod in it. So, like, if you just look at it from one angle, I'm seeing like 7 of these flat Earth pods. And they're in these triangles, so they end up looking like that, all-seeing eye in the triangle, but they're flat Earth pods in a triangle. And another thing you see on that triangle is some ways, if you were to leave over the Antarctic ice wall, you would go to nowhere land on most directions. But then there's a few directions where if you get them just right, you would go to another flat Earth pod very quickly. It's almost like right there if you happen to go the right direction. And by the way, just the way, even though I wrote this purely as science fiction, what looks interesting is that those connecting points, they happen to be exactly at South Africa, the tip of South America and Australia. And each flat Earth disk has 3 connecting points, and they all happen to be right, where those continents end. So that's sort of amazing. So or you can just say that's why I picked it for the science fiction, because I just created this. I have no way of knowing if there's any truth to it or if it's just an idea. But if you go to the Kickstarter, you can see that. So if you go to the Kickstarter, you place an order for $5, you get the postcard with the picture, some of the compelling flat Earth arguments on the back, and the Frisbee. So you get the Frisbee for $5 plus the postcard. Or get multiple ones if you want. But at least go to the Kickstarter so you can see that second image. And if you go to the updates on the Kickstarter, you'll see some of the other ideas. I'll just mention one of them. So the International Space Station, if you followed that, NASA has that satellite floating with people living on it. So if you take that map, if you take that route of the International Space Station on a spherical map, it's making this parabolic route that goes northern hemisphere to southern hemisphere and back again, and this seemingly crazy route that it takes. But if you plot that route from the spherical map or the Mercator projection and you put it onto the flat Earth map, it becomes a perfect circle. The ISS on the flat Earth map, it's just making a circle. It's like a hula hoop going around and around. It might shift its center point a little bit, but it's just making circles, just doing laps up there. So that's pretty cool. You can see that and some of the other interesting updates, and I'll add a few more updates before the project ends. So whether you're going to order the Frisbee or not, you want to go and take a look at that project on Kickstarter, Flat Earth Frisbee.
We've got John Rapp with us today. He joins us here on Build, Grow, and Enjoy, talking about the Flat Earth Frisbee. An amazing conversation today with this very, very intelligent individual. John Rapp has a Flat Earth Frisbee, and it is just absolutely, absolutely amazing. Let's talk movie plots like time travel and aliens. They work better on Flat Earth. Explain.
Yeah, so that's the funny thing, is YouTube 2015 is like flooded with flat Earth videos. It's like 30,000 so far this year. 2014 was a pretty good year for flat Earth videos. There were 500. So it's way up in 2015, but it was on the map in 2014. Now here's the crazy thing. In 2013, I started writing comic books. The first one was called Electromagnet. And in this comic book, the major part of the plot is they're trying to, they being the enemies in the comic book, they're trying to build this grid system where they cover the entire Earth with towers or antennas, so they can sort of electronically control. It's, you got to read the whole comic book. But basically, they're trying to cover the entire Earth in radio towers. And I sort of was inspired by this idea by all the cell phone towers that you see pop up. Lots of times you'll see like American flags, and you'll see they look like extra chunky. And you think, why the American flag is so chunky? Oh, it's actually a radio tower. And there's a lot of things like that. There's a lot of towers that you don't realize that are hidden places. There's also towers surrounding the land, like these oil drilling rigs. Well, I mean, they're oil drilling rigs, but they also have towers with communications equipment on them. So that's the book I started writing. And as I was writing it, I was sort of embarrassed that I was using towers, not satellites, because I know, like in Independence Day, they're using satellites because of the curvature of the Earth. They've got to use satellites for communications. And I'm thinking people are going to think I'm an idiot because I'm using, something that would only work on a flat Earth. And in fact, I have a couple other scenes that are things that only work on a flat Earth. They wouldn't work. But at some point, I just embraced the concept, and I just told the readers, this comic book has alternative physics, alternative history, alternative cosmology. It's just a comic book. Don't worry about it. That's what I said in 2013. But now it's suddenly become, this flat Earth is becoming a popular concept. And I think that science fiction could be one of the things that's making it popular, because I picked this flat Earth because I just wanted to do my sci-fi on a flat Earth. And I think that a lot of other people are going to like it for that same reason. For example, one thing that's never seemed to work in movies is time travel. There's a lot of, obstacles, and you watch a movie about time travel, and then you think up 50 reasons why it doesn't work. And one of the main reasons it doesn't work is the Earth is moving. In our current cosmology, the Earth is traveling thousands of miles per hour. Well, if you traveled, 25 years to the past, the Earth is millions of miles away from where it used to be. I mean, you're going to end up in the middle of space. That's not going to work. But on the flat Earth model, where the Earth is, flat and stationary, time travel, at least theoretically, it works. Another popular concept in movies is aliens, but it's tough to do alien movies. You can have Star Trek, where you're like traveling around, to visit the aliens. Or you could have a movie, like Independence Day, where the aliens come here, but then they don't come back for like 50 years because they're coming from far away. It's the same concept in Ender's Game, where you travel there. But on the flat Earth, where you have this pod model, aliens could be just in another pod. They could get here in a day, or they can get here at least in a couple of days. And it becomes more realistic and even more threatening if you think about that some of the people who make the movies, there's this concept that a book gets written or a movie gets made, and all of a sudden there's something like that in the news 10 or 20 years or 30 years later. Well, they've been making movies about aliens for 100 years, but no aliens have showed up yet. Well, because the aliens are more than 100 years away on the current cosmology. But on the flat Earth cosmology, they could be like a week away. So, if you want aliens here, whether it's for your sci-fi or for news, I mean, you can get them here quickly on a flat Earth. So, we've got the communications, on the flat Earth. You can sort of enclose a population. You've got time travel doable on a flat Earth. Aliens, a day or two away on the flat Earth. I think it's got a lot of sci-fi potential. And then everyone who works in the industry I mean, do they want to keep making Star Trek and Star Wars, or do they want a chance to reboot and give the young guys a chance to write some new fiction? I mean, George Lucas is not going to switch to flat Earth cosmology now. So it's a sort of chance to get on the ground floor and to make some sci-fi that's more believable. I don't know. This might be too much. I mean, if you can't get the science establishment to go along with flat Earth, then, it might just seem ridiculous in the sci-fi, but maybe not. I think it's interesting. I think if it becomes popular, you'll see more of it.
John Rapp with us today here on Build, Grow, and Enjoy. We've got a little bit more time left here with John Rapp on our program this week. John, before we get back into the next topic here, let's give the folks that are tuning in late or didn't get the details the first time, explain to us what you're doing with Kickstarter.
Yeah, it's a Frisbee. I've been doing a Kickstarter project every month for my new outlet that I call Annandale Comics, which is basically just comic books that I write. At some point, I'll get some other people involved, but I don't have a lot of money to work with, so I just write them myself, and I collaborate with freelancers to draw them, and then I do a project each month on Kickstarter. So I have some comic books to finish, but I wanted to keep making a monthly project because I have this monthly, I call it a vote card because it's basically a postcard, but I call it a vote card because I do one every month, and the more people who back the project, the better the project gets. So for example, right now I have a Frisbee that's on Kickstarter. If you search Flat Earth Frisbee, you can see it. And I have a postcard, and I call that postcard a vote card because if 100 people back the project, which means buy the postcard or the Frisbee or both, then I'm going to unlock the next portion of the Kickstarter, which in this case would be the Flat Earth map on a circular mouse pad, which I think will also look cool. So we'll have the Flat Earth Frisbee and the Flat Earth mouse pad if we get 100 backers. And then if we get 200 backers, I'll unlock something else because, I mean, I'm not like a billionaire. People need to back the project for me to place the order for the product and get a volume discount, and then I mail them out to everybody. So, if you tried to buy just, design a Frisbee or a mouse pad and just print one for yourself, I mean, if you're just doing it for yourself, you probably can do it like $20, $25 in a few hours of your time. But if we do it, if 100 of us get together and place the order, through this Kickstarter, then I spend a couple hours designing it. We order in volume, we get the price down to, $5 per unit, something like that. And then, plus shipping, so I got to ship them out to everybody. But still, you probably get it for $10 instead of $25. So I'm thinking this Kickstarter is the sort of Flat Earth tchotchke central. We're starting with a Frisbee, we've got a goal of a mouse pad, and we can do more stuff if we get more backers. So I want to sort of get the Flat Earth community together on this Kickstarter. Frisbees, I don't know, is it the coolest thing? Should we have done the mouse pad first? I don't know, but let's start somewhere. And I started with the Frisbee because that's the idea that was fun to me. I think I've even heard people describe the Flat Earth as it's like a Frisbee. Instead, the spherical Earth is like a ball, the Flat Earth is like a Frisbee. So I sort of went with that. And I actually ordered, as a test print, I ordered the first 50, so I've got them. I mean, they're right here. There's a box of them sitting right next to me. So that's like a guarantee. You place the order, I'll ship it out to you.
We've got John Rapp with us today here on Build, Grow, and Enjoy. Intercontinental plane routes are straight lines on a flat Earth map. Explain.
Sure. We mentioned this before with the flight from Auckland to Santiago, Auckland to Santiago that stops in San Francisco. They've got other flights. In fact, a very popular hub, intercontinental flight hub, is Abu Dhabi, which if you look on the Flat Earth map where that is, it's somewhat central. If you're flying from Australia or from, let's say, South America to Africa or to Australia or to New Zealand, you might be taking a route that both starts and ends in the southern hemisphere. But it stops to gas north of both of those places in Abu Dhabi. And there's it's like a transit hub. There's tons of flights that stop there and refuel. Why would they be doing this? Like, if this isn't on the way, why would they be doing this? So my challenge to the listeners is, next time you book an international flight, or you even think about booking an international flight, you're just like looking at them, thinking what you want to do. Take a look at the map that they give you, the travel site gives you. It's probably going to be the rectangular Mercator projection. Now, a rectangle already tells you something's wrong, because rectangles don't fit on a sphere. They fit on cans, like a Campbell soup can. So, and then if you look at the flight route, it's probably going to show it with this arc, this curve, and you might think in your head, why is the plane taking a curve? Why are they not taking a straight line from point A to point B? And then if it's a long flight that stops to refuel or to let passengers on and off, that's going to be a really good one. Because now, even if you plot the route yourself and not look at what the airline gives you, you're going to end up with a triangular route. Starts at point A, goes to point B, stops at C to refuel, and makes this, might even be like a right angle or some type of, triangular route to get there. Okay, so you sort of plotted that route on the Mercator projection. Put that on half your screen. On the other half of your screen, go to my Kickstarter project where we've got a picture of the Flat Earth Frisbee. Take a screenshot of that and plot those same points on the Frisbee. And you'll find that it becomes a straight line. I mean, I don't have to know what route you're taking, because I've seen enough of these to know that you're going to see something that's going to make you question at least if nothing else, at least it's going to make you question the Mercator projection, that rectangular map that you see all the time. Because the routes are triangles on the Mercator projection, but they're straight lines, or at least a lot closer to a straight line on the Flat Earth circular map. So, airlines, they want to save money on gas, they want to save time, they want to make straight routes. What if one map is showing you a straight line and the other map is showing you a triangle? I mean, one of them's probably closer to reality than the other one, and I'll let the listener determine for themselves which one they think it is.
We've got John Rapp with us today. He joins us here on our program on Build, Grow, and Enjoy. We've got a great offer here for you about the Frisbee. Go ahead and we've got a few moments here. Go ahead and tell us about this great offer again, how people can donate, contribute, and do all that, and then we'll wrap up the program here.
Okay. It's go to Kickstarter, search Flat Earth Frisbee. You get the Frisbee and a postcard for $5. It's the way Kickstarter works. It's technically you're like donating, but I'm also agreeing to send you a reward. So you'll get basically for $5 you'll get the Frisbee. There was one other thing I wanted to mention, and it's going back to this Flat Earth, because I know that people, when they hear it, they kind of think like they don't want to fill their brain with nonsense. Like, that's too stupid. Like, the Earth is a sphere, and they just know that, They don't want to talk about Flat Earth. So I wanted to mention the one reason. I don't know if it's the one reason, but I want to mention a reason that I think that even, the most ardent supporter of spherical Earth science I would hope agree with. And here's the reason. If you watch some of the science programs that are on TV, you'll see a lot of science that mentions things like wormholes, dark matter, quantum entanglement, all these like really fanciful concepts, faster than light speed and these kind of things. These things that you don't think sound plausible, but we're told that the science checks out. you know, and I think that what that tells me is that, let me use an example of what that tells me first. Let's say you're building a Lego puzzle, if you have kids and you build Legos with them. You make a mistake, but you don't realize it and you keep building. And then it's like an hour later and the thing doesn't fit together anymore. And you can either make it, so force it fit by doing a lot of additional mistakes to sort of make the pieces fit together, or you can undo the Lego puzzle to an hour ago where you made the mistake, start from where you knew it was still correct, and then build again very carefully. So I think this is the state we're in right now. I don't know where or when something went wrong with science, but I think when they're making all these wormholes and dark matter and all this stuff that we can't even conceptualize, I think that there's something wrong. And I think that the same way that people have taken to YouTube and become citizen journalists, I think now is the time for people to go to YouTube and become citizen theorists. And I think going back to a time when we thought the Earth was flat and sort of redoing the science that we already did like 300-400 years ago, whatever, maybe like the top universities don't want to do that, but maybe that's an opportunity for people on YouTube to do that and start compiling the results, because maybe you're going to avoid the mistake this time. Like, if you assume that there was some mistake made and we've been compounding on it by believing it was true for 50, 100, 150 years, whatever it is, then this is the chance to go back to, okay, let's try to measure the shape of the Earth. Let's start from there, and then let's start building the science forward again, and maybe we can get to the correct cosmology without all the stuff that sounds like science fiction. So I think that's one of the goals, and the way the Frisbee ties into that, the Flat Earth Frisbee on Kickstarter, is you go to Kickstarter, you put down your $5, you get the Frisbee. You now have this Frisbee in your hand with a Flat Earth map on it, and you can start a conversation with someone, because if you try to start it without that map in your hand and you try to explain it, you're just going to hear laughter. I mean, who wants to hear about flat Earth? It just sounds like so crazy. But when you've got the disc in your hand and you can start talking and you can start saying all the reasons why you want to trace your steps on this science, and this cosmology of the Earth, I think you will find something of value. I don't know what shape of the Earth you're going to find, but I think you will find some value.
Well, John, I appreciate you being with us today. Thanks for being on our broadcast, and good luck with the project, and we'll talk soon.
All right, thank you, Jiggy.
Thank you, my friend. We're going to take a time out. We'll see you next week here on Build, Grow, and